Okay, good evening. We will be starting on the other side of the other part of the lesson. So today we'll be talking about why is water a universal solvent. So mainly the objective is to recognize that water is able to dissolve in many substances, but what makes water so unique that it is commonly found in is commonly used to dissolve a lot of other substances. So first of all is water is always recognized as one of the main biological solvent. Okay, in this case, water is actually an example of a liquid, and like we shared in the previous lesson, most solvents are liquid in nature. So water is a very good liquid solvent as it can dissolve many substances. So if you look at items around you, most of the time it can be dissolved in with water, and that's why most of your chemical reactions they are actually very favorable and they tend to be dissolved and they tend to require or use water to drive the reaction. Now, water makes up 90% of our body masses. So every time when you go, like let's say you go for a slimming session, you actually put yourself in a sauna, then you go and then you weigh your weight, then you realize that you became lighter. Now, the reason is because when you sweat, you lose a lot of water mass. This will then reduce your whole body mass to become lower, that such that when you measure, it gives you an idea that you have lost weight. What you have lost is just water mass, and this can be recovered when you just drink a glass of water. So for some, if you go to any vigorous activity that requires you to sweat a lot, you naturally will lose a little bit of water, but not so drastically such that you will lose like 1 kg of water. You will just lose a few grams. Another thing is most of this water, where is it found in your body? It's not that when you cut yourself, you realize you are dripping water. No. Instead, all this water are mainly found in blood. Why blood? Because blood is fluid enough. It has to be fluid enough for you to transport substances around your body. So water is a natural choice. And that water is important to our body as it helps to dissolve and transport not just the food substances you eat, but also the mineral salts like the vitamins and other gas to other parts of the body. Gas in the form of oxygen and carbon dioxide gas. So all these are mainly part of a component of your blood system. Like oxygen is carried by your red blood cells, and carbon dioxide is carried by your blood plasma. So some use of solvents and solution. Solutions and solvents are very useful at home, in industries and agriculture. So these are the items, these are the ones where you can recognize that where most of the solutions are being used. Okay, what are some of these solutions? It can be detergent for washing. It can even be water to cool down your machineries in the industry to bring down the temperature. Agriculture, you can use water to grow your plants and of course to create medicine. So one good example is hydroponics, whereby you use water to grow plant. And this one, do take note, there isn't a need for soil for this particular process as the nutrients are dissolved in the water itself and the plant just have to absorb the nutrients through their roots. These are some examples of using water at the different areas of places of interest. Like at home, you can use water for cooking, washing, and bathing. Now in exam, you might be required to give some examples from here. So if I were you, I will try to remember what is actually provided here. Water can also be used, also be dissolved in detergent. That is used for cleaning and other uses as well. But generally, it's used for cooking, washing, and bathing. Next is the industry. So water can also be used as one of the raw materials to manufacture food, substances, drinks, textile, soap, and cement. Most of the items they use in industry to make things tend to use water. Ethanol is also used for perfume. So ethanol is another example of solvent use. So you can take note that water is not the only solvent, but there are other types of solvents as well. And still made from solid solution of iron and carbon. So you can see it's an example of a solution, and these are all usually used widely in the construction industry. Okay, in agriculture, water can even be dissolved in fertilizers, which are then absorbed by the roots of the plants, so that they will help the plants to actually grow stronger, grow healthier. For medicine, water or solution, can be used in the form of antiseptic solution such as iodine to dissolve in alcohol to disinfect wounds, where alcohol is the solvent and iodine is the solute. So a combination of drugs is needed to treat any illnesses, and these drugs can then dissolve in common solvents like water. So for example, when you eat Panadol, Panadol itself is a solid, so it can be considered as a solute. When you take it in, you will also want to add to drink water to bring about to dissolve this Panadol inside your body or even your mouth for you to swallow easily. Okay, so that is the main portion of how solvent is actually used, or water is actually a universal solvent. Now let's look at what are some factors that can actually affect the solubility of a solute in a solvent. So what is meant by solubility? This is a very important definition which you all have to memorize for exam. So first of all, solubility is the maximum amount of the substance at a given amount of that can dissolve in a given amount of solvent at a temperature. Why? So from this statement, you can see that temperature can actually affect solubility. The volume of solvent used can also affect solubility, and definitely the mass of the solute can also affect it. So these are the three key things that you need to write in your exams to get the maximum mark. And different types of solid will have different solubility in a solvent, like the solid of sand. The solubility of sand is very different from the solubility of salt. Both are solid, but one can dissolve in water, the other cannot. Sand cannot dissolve in water, salt can. So sand actually has a lower solubility in water as compared to salt, which has a higher solubility in water. So these are the examples. Some of you ask, do I need to memorize these numbers? No need. But what you need to know is that solubility, right? The bigger the number, okay, which is the solubility, bigger the number, the more soluble the solid is. So if you compare over here, copper 2 sulfate, salt, and sugar, sugar is able to dissolve much readily as compared to copper 2 sulfate. So this is most soluble, and this is least soluble based on the number given. So in exam, even though they don't give you the name of the solid, but they give you the name, the number of the solubility, you are required to know how to tell whether is it soluble or not soluble and rearrange the order. Factors affecting solubility, in this case we use salt and baking soda, can be affected by the type of solute. Now do take a look at, actually this is actually using a fixed volume. That means the volume used here is the same for both situations, and I will assume that the temperature is also fixed, which is the same. Now the only thing that's different is, number one, this is salt, this is soda, and the mass. So in terms of solubility, you will see the units as grams per cm cube. Oh, sorry, I wouldn't say grams per cm cube, but mainly to compare it later on, they have to have the same kind of units of measurement. So in this case, right, which one do you think is more soluble? The answer would be 15 grams of salt. Why? Because 15 grams of salt requires is having more mass that can be dissolved in 100 cm cube of water. So having a bigger number here, that means you are actually using the water 100 cm cube of water is able to dissolve 15 grams of the solid. While down here is 100 cm cube of water is able to dissolve a lesser mass of solid. So in this case, salt is actually more soluble than baking soda. Now let's look at the other side of the rule where you use iodine but you use different solvent. Everything else is the same. So what you can see is that iodine is able to dissolve in alcohol more than in water. Why is this so? Because you can actually dissolve 10 grams of iodine as compared to 0.2 grams of iodine in water. So this means that iodine is able to dissolve better in alcohol than in water. In other words, the type of solvent can also influence or affect the solubility of the substance. Next is temperature. Temperature plays an important role in affecting solubility. Where let's say you pour you pour Milo powder into hot water as compared to Milo powder in cold water. You realize that you are able to dissolve the Milo powder much easily in hot water, assuming you do not stir it at all. It will naturally, the temperature will naturally help to dissolve the solute faster. Why is this so? Because a higher temperature will increase the kinetic energy of the particles. So they tend to break down easily such that it will mingle and mix around in the water much faster or the solvent much faster. Therefore, higher temperature, you may have higher solubility of the substance. Okay, so over here, just to recap, we have talked about the factors that affect solubility, and there are two main things that are the factors. Number one, it will be the type of solute, and number two, it will be the type of solvent. Okay, so number one is type of solute. Number two, type of solvent. And number three, the temperature. These will actually affect the solubility of materials. Then in the previous segment, we talked about how water can be used in different environmental conditions. Like in medicine, you can use it to actually create medicine. You can use it to grow plants in agriculture. You can also use it to manufacture industrial materials in the industries and at home, which is commonly used also. Okay, and of course the individual substances, and that water is actually a very good solvent that can dissolve in many substances such as sugar, salt, alcohol, and soluble food substances. So in our next lesson, we'll be talking more towards about what are the factors that could actually affect the rate of dissolving, and if you want, you can pause here to recap what you have learned. Otherwise, you can always click the next video to actually follow up in the next segment or this particular for this particular segment.